All right, so let's suppose we have an example like so, where it says we have a ball, it's thrown upward to a height of h sub 0 meters, and then after each bounce, the ball rebounds to a fraction of its previous height. So kind of think about what's happening here. So let's see, we throw a ball up to a height of h sub 0, and then it'll come back down, but then it'll just rebound to a fraction of its height, meaning it won't bounce quite as high as the throw was, and then it comes back down, and then if we let it to keep bouncing, okay, it won't bounce as high right as it originally was thrown up. Okay, so it's just a fraction of its previous height. So you kind of see, if we kind of let it keep bouncing, you can kind of see that the height of that ball is going to decline, okay, as it continues to bounce. So let's suppose we have the initial height is 60, and then the fraction of that bounce, 0.25, so just a quarter of the initial height. So what we want to do is find the first terms in this sequence, okay? So let's suppose that first we have no bounce at all, okay? So that means, okay, well, what's our initial height of it, right? Well, we know that we're throwing it upwards of 60 meters, and then it would rebound or bounce back at a quarter of its height. But remember, we're not bouncing or throwing it at all, right? For it to do that bounce. So here we just raise it to the 0 power. So then we would just simply get 60 times anything raised to the first power, or the 0 power is 1. And so, yep, that initial height would be 60. Okay, so that kind of makes sense, right? No bouncing at all. Well, what happens if we have the first bounce? Okay, so now it will, okay, do that rebound to a quarter of its height. Okay, so that first bounce, so let's see what that would be. Okay, so we just simply raise that 0.25 to the first power, multiply that by 60, and you'll see that you actually get just simply 15 meters. Okay, so that would be the fraction of its height right after it does that first bounce. Well, what happens after the second bounce? Okay, well, now we're letting it drop twice, so we can now see that it's going to be just a fraction of its height with the second bounce. Okay, so not quite as high is what we would think. Okay, so you would raise 0.25 to the second power, multiply that by 60, and we would get 3.750. Okay, so you can see it's starting to decline, so that kind of makes sense. All right, well, what happens with the third bounce? Okay, well, this time, right, you would just simply raise that to the third power, and we end up getting 0.938. Okay, so all of these, this is the first four terms that we would get, okay, in that particular sequence. And it makes sense that the values are dropping, right? Because you think about the height of that, each of the bounces gets smaller and smaller each time. Okay, so then using that idea, we want to see if we can find the explicit formula for that, okay? Well, if you take note of exactly what we have, now we can say that if you look at this subscript and this exponent, what do you notice? They're the same each time, okay? So we can use that to help us form this explicit formula. So basically we can say h sub n, okay, we just pick a value n, right, for the nth term. H sub n is just simply equal to 60 times 0.25 raised to the nth power. Okay, so that would be the actual formula that we would use to find the values within that sequence. All right, now let's suppose we have the following infinite series. Okay, so now we're not saying sequences anymore. We're going to say series, and that's now because we have this summation. Okay, and we know that it's infinite because k is going from 1 up to infinity. Okay, so we have the summation of k going from 1 to infinity of 90 times 0.1 raised to the kth power. So we want to find the first four partial sums. So we want to find each of these values here in that particular series. Okay, so all you would do is start with the first value of k. So basically let k be equal to 1, since that's where we're starting. and you're simply going to plug in. So we're saying summation as k goes to 1 to 1. So we have 90 times 0.1 raised to the first power, and that's just simply going to be 9, okay? So that would be the first value in that sequence. Well, now, what would the next sum be? Okay, this time k is going from 1 up to 2, so 90 times a 0.1 to the second power. So remember the summation, that means plus, right? Sums, that summation, right, means sum, okay? So that means we're adding. So first you're going to do to the first power, then plus, repeat that now to the second power, okay? So just put that all together and you will end up getting 9.9. All right, and so you would just simply keep that same pattern every time. So here k is now going up to 3. Okay, so basically what you're doing is you're going to take the first two, okay, you're going to add those together, and then the third one is just going to be to the third power, okay? So instead of having to write it, all those summations so many times, you can take the first two that you know, and then do plus the 90, the 0.1 raised to the third power, okay? All right, and that actually turned out to be 9.999, okay? So maybe you can start seeing the pattern here. So now find the fourth one. K is going from 1 to 4. So you have the 90 times the 0.1 to the kth power, okay? So basically all you would do is you would take all of the ones that you have previously found, and then the fourth one, right, you would just simply raise it to the fourth power, okay? So put all those together, add them up, you would get 9.9999, okay? So that would be the first 4 partial sums, okay? All right, so now let's see if we can figure out, okay, well, what's the formula that we can use so that we can find the nth partial sum, okay? Well, if we take a look at our patterns here, okay, let's take a look at S sub 2. So what did S sub 2 look like? Well, it was equal to 9.9. If we think about the fraction, that's just 99 over 10, okay, not 100, but over 10 because it's 9.9. Well, that's the same thing as saying 1 over 10 times 99, right? Well, try to see if we can get this number inside, right, that we can do something maybe with this 10. Okay, how can we sort of get it, this 99 as a multiple of 10, right? Well, 99 is the same thing as 100 minus 1, okay? So you can start seeing how we can then kind of take the 10, this 100, kind of relate it to this 10 on the bottom. So we can say this is the same thing as 1 over 10 times 10 squared minus 1. Okay, well, if we were to distribute all this through 10 squared over 10 minus 1 over 10, okay? Well, simplify this. This is just 10 minus 1 over 10, okay? Because, of course, that 10 squared over 10 simplifies to just 10, okay? Well, what can we do from here, okay? What if we then say, okay, I'm going to just come over here now. We said we have this 10 minus 1 over 10, okay? Well, that is the same thing as saying 10 minus 1 over 10 to the first power, right? Okay, well, let's compare now with our subscript that we started out with, all right, to this little subscript here. Okay, well, what's the relationship with the two? Okay, looks like it's just one less, right? So we can rewrite this as 10 minus 1 over 10 to the 2 minus 1, right? Because we said it's just one less. Okay, so this is the same. Well, let's now compare what we just did here with our n sub 2 and use that same idea to find the S sub n. Okay, well, using this pattern that we have over here, we can just simply say, well, we have 10 minus 1 over 10 to the, what's our subscript n? So 10 to the n minus 1, right? So based off of what we had over here, we did the subscript minus 1, okay? So therefore, we can say that this is a formula, right, that we can use for the nth partial sum, okay? All right, well then, what kind of conjecture, all right, can we then make about the values of our series, okay? Well, look like as our n, right, was getting bigger and bigger and bigger, right, what was happening to our values of our s, right, our partial sums? Well, it looked like it was converging to 10, okay? So that's the conjecture we can make, okay? We can say that it converges, and in this case, right, the limit, right, approaches 10, okay? So as the value of k is getting bigger and bigger and bigger, looks like our sum here, our infinite series, is equal or approaching 10.